Hello, my name is Malte Stötzner. I am a research assistant at the University of Stuttgart in Germany. In this demonstration, we extend our paper accepted at the main track of this conference and show how to holistically manage deployment variability using Variability4TOSCA and OpenTOSCA Vintner. In our motivating scenario, we act as a software as a service provider. This provider offers different plans for managed instances of a webshop application, which consists of a shop component and a database. On the left, the community plan is shown. This plan is for free and thus minimized for costs. In this plan, the shop component is deployed on a virtual machine along with an SQLite database. The shop component is implemented by the community deployment artifact, which implements the core functionality of the shop component and is configured to use the SQLite dialect. Multiple deployment technologies are used to deploy this variant. Terraform for creating the virtual machine and Ansible for installing the shop component on this virtual machine. On the right, the enterprise plan is shown. This is a paid plan suitable for production workload. The shop component is deployed along with a MySQL database on Google Cloud Platform with autoscaling and high availability enabled. The shop component is implemented by the enterprise deployment artifact, which implements the core functionality of the shop component, but also additional analytical reporting functionalities, and is configured to use the MySQL dialect. In this variant, we also use multiple deployment technologies, Terraform for creating the database in GCP and Ansible for deploying the shop component on GCP. To model this kind of deployment variability, we extended Tosca by conditional elements and introduced Variability4TOSCA. Let's have a look at the Variability4TOSCA model of our motivating scenario. Here, we model variability inputs. For this demonstration, the variability input plan is of interest. This input specifies which plan is required. These inputs are then used in variability conditions to model conditional elements. Here, we model reusable variability conditions. For example, is community checks if the variability input plan equals to community. There's actually a third plan, the business plan, which we do not discuss for brevity. Here, we model the shop component. To conditionally configure the shop component, we introduced conditional properties. For example, the database dialect is set to the value SQLite if the SQLite database is present, and to MySQL if the MySQL database is present. We also introduced conditional relationships. For example, this database connection connects to the SQLite database and is only present if the community plan is selected. We also introduced conditional components. For example, the MySQL database has a condition assigned checking for the selected plan. We implemented OpenTOSCA Vintner, which supports Variability4TOSCA. Let's deploy the enterprise plan of our motivating scenario using OpenTOSCA Vintner and the Tosca orchestrator Unfurl. First, we import the Variability4TOSCA model and initialize an application instance. Our goal is to deploy the enterprise plan. Therefore, we specify the following variability inputs. As you can see here, we specify that the required plan is enterprise. Then we can resolve the variability and generate a Tosca-compliant model. Now we can deploy the application. And thereby, we also provide additional inputs such as credentials to GCP. OpenTOSCA Vintner instructs Unfurl to deploy the generated Tosca model, and Unfurl uses Terraform and Ansible in the background to deploy the enterprise plan on GCP. The application is now deployed. We can verify this by opening the application in our browser. Here we can see that we first of all successfully reached our application, secondly that the enterprise artifact is deployed, and thirdly that we are able to connect to our database using the MySQL dialect.